Following up on the construction of 80-meter inverted V antenna with loading coils which had been posted yesterday. I have fixed both 2.25 meter insulated copper wire and 5.25 meter insulated copper wire to the loading coil. After that, I scraped off the insulation at about 2 cm of terminal portion of the enameled copper wire of the loading coil. Same knife was used to remove the insulation from the terminal portion of the insulated copper wire. Then the ends of insulated copper wire and enameled copper wire were twisted together and firmly fixed. After repeating the procedure for all the 4 connections of the 2 coils, ends were secured with insulation tape. Insulated copper wire lengths were checked so as to be almost equal on both sides of the antenna. Extra portion was folded back and pressed with pliers to mark the positions. Now the 2 loading coils and 2 sets of antenna elements attached to either side are ready for mounting. Antenna elements have been made into coils and secured with tape so as to prevent being entangled during storage. They will be uncoiled during mounting process. Next step was to fix a piece of 1.25-inch PVC pipe between the 5.25 meter antenna elements. This was meant for fixing onto the mast. Insulations at the ends of the wires were removed for connection to the coaxial cable. This cut end of 15 meter long RG213 cable does not have a connector. The inner conductor and outer shield were scraped with a knife to remove any dirt or oxide coating. The outer shield was connected to one of the antenna elements fixed on a PVC pipe to hold it firm. Connection of coax shield to the antenna wire was covered with insulation tape and the coax end fixed to the PVC pipe with the same tape to prevent movement once the antenna is mounted. Central conductor of RG213 was then connected to the other half of the antenna. The joint was further covered with insulation tape so the whole assembly was secure and ready for mounting. Using a step ladder, I tied the piece of PVC pipe with antenna connected to a fiberglass pole which was already having my 40-10 meter inverted V dipole at the top. Tied a nylon wire to one end of the antenna and the other end to half of a coconut shell to throw it over the terrace fence to get the antenna tip down to the garden. Coconut shell would not cause much damage even if it falls on something on the way. Here you can see the other end of RG213 cable, upper end of an HLF 200 cable coming from the shack and an SO239 barrel connector for joining the two together. Now the 2 cables have been joined together using the SO239 barrel connector as both cables have PL259 connectors as the termination. After a lot more effort, the antenna is now ready with both ends tied on the garden fence with nylon ropes at around 6 feet height. Initial test on very low power at 3.6 MHz showed an SWR of about 4:1, not a happy situation. Tested near the lower end of the band and it was slightly higher. Checked near the upper end of the band and it was slightly lower, still beyond the tunable limit of the automatic internal tuner of my FT710 radio. Checked the SWR on 14.2 MHz as the design instruction by VU2XTO had mentioned that the 20 meter part has to be tuned to 1:1 SWR before adjusting the 80 meter part. To my pleasant surprise, I found an SWR of 1:1. Checked near the upper end of the 20 meter band and the SWR was between 1.5 and 2, well within the tunable range of my FT710 radio. I did check on 40 meter as well, as someone on X, Twitter, had asked about the possibility of working 40 meter. The SWR was higher than that noted on 80 meter. Finally, I checked near the lower end of 20 meter band. That was also 1:1. Now I have a perfectly tuned antenna for 20 meter. That is first step success as per design. By the time I had finished the job, 80 meter net on 3.6 MHz had long been over and there were no stations to be heard on 80 meter. Today evening I will test the performance of my new antenna on 20 meter as it resonates well for a large part of the 20 meter band without tuner. Tomorrow morning I will try to listen to 80 meter net at 7:15 am to see whether the reception is anyway better than my 40-10 meter inverted V dipole. After that I will embark on tuning the antenna for 80 meter. From the preliminary information which I have on SWR pattern across the 80 meter band, I think I will have to lengthen the terminal 2 meter part. Actually, VU2XTO had mentioned in his article that he ended up with 1.5 meter for resonance at 3.6 MHz. Let us see what happens in my case within a couple of days.